This is lecture 2 of linear regression. In lecture 1, we have found out the value of slope b is equal to n sigma xy minus sigma x sigma y divided by n sigma x square माइनस सिग्मा एक्स का होल स्क्वायर. This coefficient of regression b, that is slope, is also known as coefficient of regression, as this has been found using line of best fit y is equal to a plus bx, that is, it is a regression line of y on x, that is, y is dependent variable here and x is independent variable. This is known as regression line of y on x, and so this coefficient of regression b is denoted as byx, and this is coefficient of regression of y on x. There is another way of defining or writing byx, and that is in terms of sigma x minus x bar y minus y bar divided by sigma x minus x bar whole square. Again, we can find out this expression very easily using the normal equations we have used earlier. Let us try to find it. As you know, our regression equation is here y is equal to a plus bx, and for finding normal equations, we multiply this regression equation. First equation, just we apply sigma on both sides. This is equal to sigma a plus sigma bx. We have applied sigma on both sides. This is sigma y, and as we know, this sigma is from 1 to n, so a will be written n times, like a plus a plus a. So this will become Na. B is constant, so it will come out of sigma. Another way of writing this is, as we know, y bar is equal to sigma y by n, and x bar is equal to sigma x by n. It is very simple. It is y bar is average value of y. That is, we are adding all the observations of y and dividing it by n for finding average or mean. Likewise, x bar is average of x is summation of all observations in x divided by n. Using this, we can write sigma y as ny bar is equal to na plus b, and sigma x will be written as n x bar from here. Okay, n goes off and we get a is equal to y bar minus bx bar. We have found out the value of a. Now for other normal equation, we multiply regression equation y is equal to a plus bx by x on both sides and then take its sum, that is xy is equal to ax plus bx square. First we multiply it by x on both sides and then we are applying sigma on both sides. Sigma ax plus bx square upon it, sigma ax plus sigma bx square, or sigma xy. A is constant, so it will come out of, plus b is also constant, so it will come out. Now we will put the value of a in this expression. We have found a is equal to y bar minus b x bar. You can see here we are putting this value here. Sigma x plus b sigma x square, or sigma xy is equal to, we are multiplying it, y bar sigma x minus b x bar sigma x plus b sigma x square, or rearranging the term, sigma xy, we are bringing this, we are taking common b here, we will get sigma x square minus x bar sigma x. We can write this expression in this way. Suppose we write sigma x y minus y bar. When you will open it, what will happen? you will get first term sigma xy minus sigma x y times. Okay, so there is no problem. We have rearranged it, and then here again we have taken, we can write it by like this: sigma, this will be x into x square minus x bar sigma x. Just we have rearranged the things, or b is equal to sigma x y minus y bar divided by sigma x minus x bar. We can write it sigma x minus x bar and y minus y bar You may ask why. When we are writing in this way, we have two terms. First term is sigma x y minus y bar, and the second term is sigma x bar y minus y bar. We can show that this value is equal to 0. Okay, first term is as as it is, and the second term which we have added or subtracted here, that value is 0. We are proving it here. You can write it sigma x bar y minus sigma x bar y bar. Okay, opening this bracket, and as x bar is constant, average is always constant, sigma y minus, these two are always constant, x dot y, x bar y bar, and summation n times it will be written, so it will be n. And as you know, what is sigma y? Sigma y is n times y bar. Why? Y bar is equal to sigma y by n. Thus we can see here these both terms are same, and so addition of or subtraction of extra term is not changing numerator, and likewise extra term added or subtracted will not change denominator. So we have arrived at b yx, because regression of y on x, it is regression of y on x. So value of b is sigma x minus x bar y minus y bar divided by sigma x minus x bar whole square. Okay, this is the another equation that is very important for us. We have introduced two equations for regression coefficient of y on x. I am writing both here. Byx is equal to n sigma xy minus sigma x sigma y divided by n sigma x square minus sigma x whole square, and after some manipulation we have found another equation also here. Both are similar expression, both are similar, but this equation will help us in seeing correlation more clearly. So now we can see, let me define covariance. What is covariance? Covariance xy is equal to sigma x minus x bar y minus y bar divided by n. This is the definition of covariance xy. What is covariance? Covariance is a measure of the relationship of two random variables. Here these variables are x and y, and if we have similar variable, then we call it as variance of x. So we will use this property here, byx is equal to this equation A. I am using sigma x minus x bar y minus y bar. We will divide this by n, and sigma x minus x bar का whole square divided by n. The upper term is known as covariance of xy, and the lower term is variance of x. Covariance xy and variance of x, we write it as sigma x square. Sigma x is a standard deviation on x. Just we are manipulating it. We are multiplying numerator and denominator both by sigma y. This will be sigma x square sigma y. We can again write it at sigma x sigma y by sigma x. And this term is known as correlation, denoted by R. Thus we have found out that regression coefficient of y on x is equal to r sigma y divided by sigma x. It is important relation. Another term, till now we have regressed y on x. That is, our regression equation or best fit equation was y is equal to a plus bx. And when we regress x on y, just listen carefully. When we regress x on y, then we can write x is equal to a plus by. Although it would have been better if I would have written it c plus dy, because these constants will be different, but for the sake of continuity I am using this equation x is equal to a plus by. Okay. When we are regressing x on y, regressing x on y, then our regression coefficient will be denoted by bxy. And what will be it? Bxy numerator will be similar, x minus x bar, y minus y bar, but in the denominator we will have y minus y bar square instead of x minus x bar square. So this is the value of regression coefficient of x on y. And rearrange it, sigma x minus x bar y minus y bar, divide it by n, and the denominator term also divide this by n. Upper term is covariance of x and y, and denominator is variance of y. Again the same manipulation, covariance xy divided by sigma square, multiply, this is sigma y square, by sigma x on both numerator and denominator. This will be covariance xy divided by sigma x, sigma y, and again you know this term is correlation R. So in case of regression coefficient of x on y, this is the expression. We have both regression coefficient with us. Okay, this is regression coefficient of y on x, and this is regression coefficient of x on y. Now we will see some properties of regression. Properties. These are very simple properties. First property says bxy, byx and first property is bxy, byx and rho xy. Correlation is represented by rho xy are of same sign. How? You can see bxy is equal to r just see this way, bxy is equal to covariance xy divided by variance x and byx is equal to covariance xy divided by variance, sorry, just you should also be alert while explaining these things. bxy is equal to covariance xy divided by variance y and byx means regression coefficient of y on x is equal to covariance xy divided by variance x. As you know, variance x and variance y, these both are positive quantities because variance y is equal to sigma y square and variance x is equal to sigma x square. So these two terms are positive. So the sign of bxy and byx will be that of covariance xy and okay. So the sign of bxy and byx will be same. Okay. Second property is rho xy is the geometric mean between bxy and byx. You can find it out. Byx into bxy is equal to r sigma y sigma x into r sigma x by sigma y. This will be r square So from this you can say that bxy and byx are geometric mean for correlation. So mod R is geometric mean between bxy and byx. Third property says the product of byx and bxy, value of this will lie between 0 and 1. As we know, value of r square lies between 0 and 1, and r square is equal to this one. So value of byx and bxy, product of the two, will lie between 0 and 1. Another very important property, we have discussed it in lecture 1 also. The two regression lines intersect at x bar y bar. X bar y bar is mean of x and mean of y. We can prove it very quickly. Just see, we are taking regression of y on x, that is the line is y is equal to a plus bx. We will take summation on both sides. Sigma y is equal to sigma a plus sigma bx, or sigma y is equal to na plus b sigma x. Since y bar is equal to sigma y by n, we can write the above. Ny bar is equal to na plus bn x bar. We have replaced sigma x by nx bar, or y bar is equal to a plus b x bar. Suppose this is equation A and this is B. Using A minus B, we get y minus y bar is equal to b x minus x bar. Here regression line is of y on x, so we can write b as byx and x minus x bar. Similarly, this shows that x two regression lines intersect at x bar y bar. Similarly, for regression line, regression of x on y can be represented as this one, and equation will be x minus x bar is equal to bxy y minus y bar. So this is the term we have to be careful whether we are regressing y on x regression of y on x, or we are regressing x on y. It is very important to understand. If we are using regression of y on x, y is here dependent variable, and when we are regressing x on y, x becomes dependent variable. We will solve numerical problems in the next lecture. Till then,